Welcome, everyone, and thank you for your interest in the IHE Pathology and Laboratory Medicine Domain Update webinar today. I am Mary Kennedy, Director of Clinical Informatics Initiatives at the College of American Pathologists and Primary Secretariat to the IHE Pathology and Laboratory Medicine Domain, also known as PALM. Our speakers today are Ricky Merrick and Raj Dash. Ricky Merrick is the co-chair of IHE PALM. She is a licensed physician in Germany and received her master's in public health from the University of California, Davis, when she started working on HL7, LOINC, and SNOMED. For 9 years, she was a consultant for the Association of Public Health Laboratories. She now serves as Staff Informatics Program's lead terminologist, providing implementation assistance for electronic data exchange for different surveillance programs at CDC, lab reporting to local jurisdictions, and case notifications for over 3 years. She also worked with NIST on the development of test cases for lab-related message validation tools. She participates in several national vocabulary harmonization projects in the laboratory and public health domains, in leadership roles in the HL7 Orders and Observations Working Group and the Lab Messaging Community of Practice. Raj Dash is also a co-chair of IHE PALM. He is a pathologist at Duke University with specialty boards in cytopathology and clinical informatics. He currently serves as the Epic Beaker Physician Champion and the Medical Director for Laboratory Information Systems, as well as the Director for Laboratory Informatics Strategy for Duke Health Systems. He is active on a number of national committees serving the College of American Pathologists, including the Informatics Committee and the Board of Governors. I would now like to turn the webinar over to Ricky Merrick. Are you on, Ricky?
I'm here. Can you guys hear me?
Yes.
Okay.
Yes,
good.
just let me know when you want to advance.
Okay. Yeah, I'm sorry I had WebEx troubles. It was spinning for like 5 minutes. So welcome, everybody. Can you please go to the next slide? So I'm going to give you an overview of what the IHE Pathology and Laboratory Medicine domain is about. I'm going to talk a little bit about all the integration profiles we have and highlight some of the new trial implementation profiles we've been working on. One is the laboratory clinical communications profile, and one is the transfusion medicine administration profile. And then I'm going to turn it over to Raj to talk about digital pathology. So next slide.
Sure.
So first, just brief introduction, what is IHE? So we're basically taking all the different standards that are out there, like HL7, that's describing, how to put things together for different use cases, and LOINC and SNOMED and DICOM. And we're looking at specific use cases that we want to cover and put those together into integration profiles. And that's what IHE is about. And so if you need to get more background on what IHE actually is doing, there's a really good YouTube video, and we have a link to that YouTube video in the slide set. And I'm assuming the slide set's going to be available afterwards for you guys. Next slide. So a little bit of background about IHE. It's arranged by domains. It started in radiology, and it's been going on for quite a while, adding domains on as we go. And obviously, as you can look at the domains, they cover different aspects of the healthcare spectrum. So laboratory as a domain has been around since 2004, and pathology since 2006. And then in 2016, I think, we merged pathology and laboratory into one domain, because we're working on a lot of similar workflows, and with automation in the chemistry side of the laboratory and the pathology side of the laboratory overlapping with requirements, we figured it's better to combine it. Each domain has a planning committee and a technical committee, and that's how each of the work groups is organized. And we have a wiki page that you can get more information about each individual domain. Can you advance to the next slide, please? Okay, 2016, there we go. And then one other thing that IHE does is, so we create these integration profiles, but we also organize ConnectUsOn. So those are week-long testing sessions where the systems developers bring their software that they want to connect with each other, and they've prepared and implemented whatever profile they are planning to test at the ConnectUsons already, and then they're trying to find partners, you know, on the other end of the profile, if they're the sender or if they're receiver, for example, for the data to be exchanged, and actually hook up, you know, their systems and work through test cases. And if they pass the ConnectUsOn, the profile in the ConnectUsOn, and successfully connect, then they can put up an integration statement, you know, attesting to that. And the other reason why we do ConnectUsons is you can think about all the things that need to happen when you're writing these profiles, but you don't really know what's going to happen until you actually, you know, put the rubber to the road and test it. And so during the ConnectUsons, a lot of issues come up and are brought up, and that is feedback back into the profile. So usually what happens is we put a profile out, often for comment first, to get some background from the domain experts, but then we put it out to trial implementation. It gets tested at the ConnectUsons, gets feedback through a couple of ConnectUsons, and then when we think it's stable enough, because we haven't gotten any more reports at ConnectUsons that it needs fixing, we move it to final text. So then the ConnectUsons usually are in different parts of the world. So if you're in the Japan area, it's October 7th through the 11th in Tokyo. And then the US one, we're into 2020 now, is always in Cleveland, Ohio in January. And then in Europe, it travels around. So in 2020, it'll be in Belgium and Brussels from March 23rd through the 27th. Next slide. So that was a background on IHE in general. So now we're going to talk a little bit more specifically about what pathology and laboratory medicine covers. So it's basically any kind of analytical or peri-analytical automated devices, any kind of testing performed in clinical laboratories or pathology laboratories on in vitro specimens from a patient or non-living material. So it could cover environmental samples. It could cover animal samples. It looks at the proper representation of structured data for the specimen management and storage, and as well as looking at dealing with sending or using laboratory data in other domains of the healthcare enterprise. And that kind of falls into overlap a little bit with public health domain, for example. So we sometimes work together across domains. And as you'll find out, we also work with outside standard development organization, like for digital pathology, for example. We're working with DICOM to make sure that we have proper domain knowledge of the DICOM standard when we're dealing with that. And Dr. Dash will talk about more about that. And then we're also it also includes transfusion medicine, and as you will see, it's one of the newer profiles we've been working on. Next slide. So these are all the different IT systems in scope that touch the laboratory in one way or another. And I'll give folks a little bit of time to digest what it says here. And then next slide. This is an overview of our integration profile. So we have the technical framework, which is final text, and that includes several different workflows. In general, technical frameworks are organized into volume 1 that gives you the overview of what the profiles are and what the scenarios and the use cases are that are covered. Volume 2 covers the specific transactions. So this is where all the detail lives about the message specifications, for example, the vocabulary that's needed for each individual use case. And as you can see, we have several volumes 2, A, B, and C, because we have to cover the detail of quite a few different profiles. Volume 2X covers all the detail that applies to the transactions in volume 2, but that's common for any of them. And then volume 3 is the content module. For us, that's really the XD Lab. So that's the CDA representation, or the CDA, using CDA for exchanging laboratory reports. So you can get to the technical framework by the link that's in here, and we just published it 2 days ago. So it's hot off the press, version 10. Usually, if even though it's final text, there are sometimes little things that show up when people are implementing, and so we have a change control process where people can provide feedback, and that's what usually triggers a new release. And we release once a year. Next slide, please. And then we have some supplements for trial implementation. So there's the interlaboratory workflow. So that's when one lab has to send testing to another lab. We have graphics and simple images and results option for the lab technical workflow. That's basically when instruments can send graphs or images back to the result manager. And then we have laboratory clinical communication, and I'm going to talk about that a little later. And then existing in the anatomic pathology domain, we have the anatomic pathology workflow in hospitals, the anatomic pathology structure report, which is a CDA, and then we have an anatomic pathology report to public health. So a brief description of all the profiles are on our wiki page, and the link is provided below. Next slide. Okay, so give it another click, please. So the first one, we deal with external workflows between clinicians, specimen collection facilities, and lab ordering and report management. So that's the LTW profile that deals with clinicians ordering from the laboratory, the LBL profile, which deals with labeling of specimen containers, the LPOCT profile that deals with point of care testing workflow, and then the laboratory clinical communications, or LCC profile, that deals with making adjustments to the orders that the clinicians have asked for. And yeah, thank you. And as you can see, the three of those in the external workflow are in final text, and LCC is a trial implementation. Subcontracting, that was the inter-lab workflow, so that goes from one lab to another lab. It's also a trial implementation one. External reporting is XD Lab, so that's reporting results using CDA to caregivers. ARPH, that's reporting to public health, and APSR, that's also reporting, that's the anatomic pathology structure report, reporting from the lab back to clinicians. So the XD Lab is kind of limited to or used for clinical laboratory results, whereas APSR obviously is focused on pathology. Next click. Gives us the internal automation. So we have LAW, which is final text and has just been published as Auto 16 as a CLSI standard. LVA, which is the pre-analytical operation, and then LSH, which is in development. So that's a specimen track automation handling. So when you're using a track to move samples from one from the analyzer to a centrifuge or something else. So that's the profile that we have in development. Next click is the transfusion medicine, and there'll be multiple profiles about transfusion medicine, but we're starting with the administration event, and I'll talk more about that in a minute. And then there's digital pathology, which will always also be a multi-profile group, but we are currently working on image acquisition, and Dr. Dash is going to talk about that. Next slide. Oh, I forgot about that. So there's one more that kind of doesn't fit exactly into this. One is the LCSD, which is basically the laboratory providing information about their test catalog to its providers. So that's the clinicians or subcontracting labs, so that they can, say these are the tests you can order from us. These are the kind of specimens we need for this test. And then there's SET, which is our new profile under development, and I'm going to talk about it a little later, but it's called specimen event tracking. And that's just basically trying to capture the entire life cycle of the specimen from collection to final storage and anything in between. Next slide. Okay, so here's our publication cycle. Can you do one more click? Because I think I didn't realize there's, click some more. And one more. Okay. So, we published the LCC, the Laboratory Clinical Communications, in June of this year. So it'll be available for ConnectUsOn going forward. We just published the PALM technical framework 2 days ago. We're planning on publishing a digital pathology white paper soonish, and Dr. Dash is going to talk more about that potentially. And then we are planning on trial supplement publications of 2 of them rather shortly as well, one for digital image acquisition and one for the transfusion medicine administration. We'll have our face-to-face meeting in November. Next slide. Okay, so newly published supplements. Next slide. Next slide. One more, please. So this is the laboratory clinical communications supplement, and it goes from the clinician or order placer to the lab or order filler, and it supports 2 things. So it works in concert with the existing LTW profile, where the clinician requests an order, a test, and then the laboratory looks at it and says, well, this test is okay, but I think there's a better one. So that's what Lab 6 is. It's an order recommendation from the laboratory back to the clinician saying, hey, we put your current order on hold. Here's a replacement order. What do you think about it? And then it gives the clinician the option to say, yeah, go ahead, and I accept your recommendation, or no, I don't want your recommendation. Or if they don't respond, it handles that situation as well. And then the other one, Lab 7, basically lets the clinician, after they've gotten results, say, I really don't think this result is right. Can you double check? Or, I've had this clinical, from a clinical perspective, I really want you to look at this part of this result. So it gives the placer a means to identify a specific thing that they have follow-up questions on. And for these, we're using the underlying 251 standard, but we've had to pre-adopt some things from HL7 2.9, which is hopefully getting published here in September. Next slide. So this is Lab 6. I've already talked through this a little bit. The black lines are the original LTW, and then the red lines is what Lab 6 is about. So it's asking for, it's making the recommendation for an order replacement or for an additional order that should be added. And then the placer being able to say, yeah, go ahead, or no, don't replace. Next slide. So that's the LTW part of things. Next slide. And the second part, as I said, is the Lab 6 LCC. Next slide. So Lab 7 is highlighted here in red, is again, as you can tell, and probably has another couple of these circles on it. So Lab 7 is the addition that's new here. The rest of it is all LTW or the interlaboratory workflow that's being used here. And it's the LCC part of the placer asking for clarification on a specific result. Next slide. Okay, the transfusion medicine is the first in its family. So this kind of shows all the different things that happen when you're dealing with blood bank issues. So if somebody donates their blood, the blood gets processed, it gets put somewhere and it's stored, and then somebody requests for it to be used on a specific patient, and somebody decides that that's okay, and then somebody goes and picks up the unit and eventually gives it to the patient. And so that's the last part, is where we currently had requests for us to be working on, and we have a couple of vendors that are interested in implementing it, and so that is why we focused on the administration, even though it's the last in the cycle. And so this includes the patient verification step, and then hopefully in the future, for the next profile, we're going to look at how is the decision made to assign it to a specific patient, and what interactions between the blood bank and the ward in the hospital need to happen. This uses 2.x as underlying standard, Loink and SNOMED CT for vocabulary. Next. Under development is the specimen event tracking. So this is where we have the event informer and the event collector. So there is somebody who knows about what's happening to the specimen. That's the event informer. And then there's somebody who wants to know what's happening to the specimen. And we have 5 different use cases. One is anything related to the collection of the specimen, where we include container preparation for the specimen collection. And then there's, shipping specimens within their hospital or between organizations. Sometimes you need to identify or re-identify, de-identify specimens. So that is covered there. We have some tracking that happens within the laboratory. So that's number 3. And then for some of the samples, they are stored in a biobank for later research, for example. And so that is a use case that is also covered with this profile. And then obviously you can have one specimen and you can create one or more specimens from it. So that's what the specimen derivation use case number 5 is for. And what we're hoping that is going to happen with this is that we're reducing the burden for automation system and processing devices when we do it. And we're going to use 251 as a base standard with a few pre-adoptions from version 2.9. I don't think we have a lot of outside vocabulary that we need to use, because it's really just saying, for example, this is the specimen and it went from here to here. Next slide. So if you have any input on specimen movements and the events that should be tracked that we're not covering yet, that would be great. And we're just worked through some change requests for orders and observations to cover some of these messages at HL7. And so we're hoping to get this specimen event tracking supplement out for comment soon. Next slide. And with that, I will stop talking and hand it over to Dr. Dash.
Thank you, Ricky. I'll be finishing up the webinar with a focus on the anatomic pathology workflow in digital pathology and our digital specimens. So I do want to recognize DICOM Working Group 26, working with IHE Pathology and Lab Medicine together to reimagine the anatomic pathology workflow, update the prior documentation. I'm sorry? And we're getting some background noise, if everyone can mute. And some use cases established to help with prioritization of what we work on first. We would like to be able to handle everything that digital pathology promises to deliver in clinical and research settings, but we have narrowed the scope. And we do have a white paper that is going to speak to the collection of profiles that are planned, as well as the first profile, which is focused on image acquisition, both coming out in a few weeks, hopefully in draft form. Next slide. So, you know, in kind of a simplistic view, we have different elements of software systems that need to work well with one another. The electronic health record, the patient record, along with the laboratory information system in green, needs to communicate with an image archive or a PAC system. And then there are things that create digital assets within a healthcare organization, such as scanners, cameras, other imaging modalities like faxotrons and ultrasound machines that are all part of pathology workflows, and they need to interact with one another. But in IHE, we have the concept of actors rather than naming systems or vended solutions. So next slide. And so this is the way that it's kind of been broken out. And so we have an order placer that is kind of like our EHR, where we recognize there's going to be a tissue collection event at the patient's bedside, and an order is placed for a pathology exam. That's received by the order filler, which is our lab information system typically. And then as the specimen is received and processed, triaged, undergoes a gross examination, there may be images taken at that point. Glass slides are produced, and there is a request for digitization of those physical tissue specimens into digital specimens. And so those requests get queued to the acquisition manager, which then kind of represents the image management system and coordinates the communication to a bank of imaging modalities or acquisition modalities. And acquisition requests, individual procedure steps are broadcast to these scanners, which will then, scan the image and store the image in an image archive of some kind of storage. As part of that pipeline, digital pipeline, there might be various analyses that are performed on those images, such as, say, counting cells, and that results in new evidence. And so we have an evidence creator actor, which might then, again, store data back into an archive, and or, of course, display information that's in the archive to the user for various types of interactions. And so the arrows flow both ways. Of course, this is at a very higher level. And so the question is, how do we break this out into the scope of activities in IHE that we can create bite-sized chunks for and try to address, but create something that's useful and usable. So next slide. And so here's kind of our thought on this is that, and what we're focusing on is the digital pathology image acquisition that you see in the top center. There are going to be a number of other profiles that speak to evidence creation, that speak to creating the image order, that speak to ordering and resulting for that pathology exam as part of that digital pathology workflow. The main technical component, the core of this, if you will, that we wanted to focus on and get into the hands of scanner vendors was the image acquisition profile, and that's what I'm going to be focused on describing now. Next slide. So these are the transactions between the actors for the digital pathology image acquisition profile. And so we've created some new transactions that speak to how the acquisition manager or the image management system speaks to the acquisition modality or the scanners to either indicate that a glass slide is forthcoming, or allow a scanner to query the acquisition manager for information for a glass slide that's appeared within its storage or rack system, and provide the necessary notifications on the status of those scans. At the same time, be able to deal directly using existing radiology transactions with PAC systems, storage systems, vendor-neutral archives, and viewers to be able to see those images. Next slide. So one of the things to consider, and that we've worked closely with the HL7 specimen domain analysis model that Ricky also leads very conveniently and helpfully for us. And her team has taken a look at the DICOM data model that exists in radiology, and we've kind of mapped it to pathology, and so we have a draft there. Next slide. In how we take the patient information, the study information, the series information, and individual images, and how it's organized in pathology versus what we know works very well in radiology. And so this is going to be published as part of the white paper, and welcome feedback on it. There's a lot of examples, I think, that can that we'll be putting into the text to provide clarification on how this would work moving forward, so that there's some clarity across all vendors on what the elements of the DICOM image file format needs to be leveraged in order to support the workflow and the transactions for IHE interoperability specs. Next slide. So we do need your help. We need help to evaluate use cases, to contribute to the profile development. We have the draft image acquisition profile available very soon. The core set of vendors that have been helping develop that, of course, are already privy to that, to those specs, and they continue to change less and less week by week, which is a good sign that we're reaching a point where wider dissemination is probably going to be worthwhile. And we want to be able to leverage this draft profile, move it to trial for trial implementation, and get a ConnectUsOn organized in 2020 for image acquisition. And that means having scanner vendors working with image management systems to demonstrate how multiple different types of scanners might work with multiple different types of image management systems, all within a healthcare organization. And in this regards, working with DICOM Working Group 26 means working with IHE POM. We're trying to be very closely coordinated when it comes to this profile. As you saw from the transaction diagram, it's a hybrid model of what's going to be HL7 V2 transactions that's very familiar in the laboratory, with a combination of radiology DICOM transactions, which are well established in the radiology IT infrastructure space. I think to create something that's very usable, very useful, has low hurdles to implement, and doesn't have a large burden of data or extras, if you will, but has a platform that will allow us to scale and include other elements of Supplement 122 from DICOM, for example. Although what we've tried to do is create a core set that we feel every scanner vendor should support, and then have the ability to scale and evolve this as we move forward. There's a current use case webpage with the URL link there. The effort required, I think, is relatively minimal compared to the return on that investment, and so I very much welcome that. And I think that might bring us to a close. Next slide. Yes, and so if you want to contribute to IHE, there's some helpful links here. please join our IHE Palm planning and technical committees. There is certainly benefits to joining IHE in an official capacity, but subject matter expertise is definitely needed. Vendor expertise is needed in whatever capacity you're willing to provide it. And certainly early input into the design of these interoperability profile specifications hopefully will mean easier implementations for vendors across a level playing field. And so welcome that participation. If there's any issues or questions, please contact the CAP staff lead that's particularly for digital pathology that's been working with DICOM and organizing the joint DICOM IHE calls, Kevin Schapp. And I think that brings us to a close. Thank you very much for your attention and welcome any questions.
I think that ends the webinar. I'm not sure if there are questions allowed on this. So,
very good.
Yes. So with that, I just want to thank Ricky and Raj for doing this presentation, and thank you to all the participants for listening into this webinar. Thank you, and goodbye.
Thank you.